Hi, we're going to discuss properties of exponents and how to use them to simplify expressions. Let's start by going through them. When you multiply a to the power m times a to the power n, you are going to add the exponents. When you divide those quantities, you are going to subtract the exponents. If you are going to raise something that has an exponent to another power, the exponents will be multiplied. If you ever have a negative exponent, that's always going to be reciprocal. If you're trying to raise a product of two quantities to the power, then each one of them is going to be raised to that power. And in a similar way, when you try to raise a quotient to a power, you're going to raise each one of the numerator and the denominator in that power. And finally, any number to the power 0 is going to be 1. So those are the properties, and let's see how they are going to work. We're going to start with some simple examples. So p to the power 4 times p to the power 3. That means we are going to have to add the exponents. It's going to be p to the power 4 plus 3, which gives us p to the power 7. When you divide, so b to the 7th power divided by b squared, that's going to be b to the power 7 minus 2, which is going to be b to the 5th power. When you have q to the power 4 and then the whole thing is to the power 3, you are going to multiply the exponents. So q to the 12th power. If you have a negative exponent, when we simplify problems, we do not allow for negative exponents to remain in our final answer. So we always want to rewrite that in some other way. So it's going to be 1 over d to the 5th power, and that's it. Here we have wy all to the power 3. That means it's going to be w to the power 3 times y to the power 3. And finally r over t to the 4th power. That's a quotient, so r to the 4th divided by t to the 4th. So that is pretty basic. It's pretty much based on the properties that you just saw. Now let's take a look at problems where you have to combine two or more. So we have this expression here, 18a cubed b to the 7th divided by 4ab to the 2nd power. Please remember that a means power 1. So what do we have here? We divide 18 by 4. Let me write that separately. 18 divided by 4 times a cubed divided by a to the 1st, that's going to be a to the power 3 minus 1, and then b to the power 7 divided by b squared is going to be b to the power 7 minus 2. So 18 divided by 4 can be simplified to 9 over 2, because remember, we're still dividing. 3 minus 1 gives you a to the power 2, and 7 minus 2, that's b to the power 5. Typically we write it as a single fraction, so it's going to be 9a squared b to the 5th divided by 2. When you have problems like this, when you have some kind of a complicated expression and there's exponent outside, what we typically do first, we're going to simplify the expression inside. Hopefully with this previous example it's going to be easier. So we have a fraction, so it's going to be 2 on the bottom. Here we're going to have p to the power 4, p to the power 4 minus 3. It's going to be q to the power 5 minus negative 2. Remember, it's 5 minus negative 2, and then the whole thing is still to the power 3. So what are we getting here? We're going to get p to the power 4 minus 3, which is 1, so just p. That's going to be q to the power 7 divided by 2, and we're still raising it to the 3rd power. So here we're going to have to raise the numerator to that power and the denominator to that power, and that means each one of these quantities will be raised to that power. So that's going to be p to the 3rd power times q to the 7th to the 3rd power divided by 2 cubed, which is 8. Let me finish this problem here. So obviously p to the 3rd, this is going to be where you multiply the exponents, so q to the power 7 times 3 is 21 divided by 8. Let me start boxing my answers so you can see where they are. This is the answer for 7, this is the answer for 8. Alright. So this here, we have a product of two things. There's an exponent outside that's going to be 2 to the power of 3 times t to the 5th to the power of 3. 2 to the 3rd is 8. T to the power of 5 to the power of 3. You multiply the exponents. That's going to be t to the 15th power. Okay. Example 10. Power 0, but you need to be very careful. No parentheses, which means then the power only applies to what immediately goes before that. So it is going to be 4. K to the power 0 is 1, and the answer is 4. We need to compare that problem with problem 11. So in problem 11 we have a situation where the whole thing is in parentheses and there's an exponent 0 outside. Doesn't matter how complicated that expression is, anything to the power 0 is going to give you 1. Okay? Alright, so with example 12, here's what you need to understand. If you have a product of more than two things in parentheses and there's an exponent outside, then the exponent goes with every single thing that we have inside. So this is how you rewrite the numerator. It's going to be 2 to the 4th, a cubed to the 4th, b cubed to the 4th, divided by, and then you do the same thing on the bottom. That exponent 2 has to go with everything on in parentheses. So 3 squared times a squared squared times b to the 4th squared. I do want to explain one thing really quick, because if you look, for example, at number 7 or number 8, we first simplified inside. Like especially number 8, we simplified inside. We can't do this here because our exponents are different. It's not the whole thing like it was example 8 where we raised the whole thing in parentheses to 1 power. It's different here and we're going to have to do it individually. So let's see what we're going to get. That's going to 2 to the 4th is 16. A to the 3rd to the 4th, multiply the exponents, a to the 12th. B to the 3rd to the 4th is going to be b to the 12th, divided by 3 squared is 9. A squared to the 2nd power, multiply the exponents, a to the 4th. B to the 4th to the 2nd power, multiply the exponents, is b to the 8th. So now we can simplify that. Can't do anything with 16 and 9. I'm going to leave that. We are going to subtract the exponents since we're dividing, so it's going to be a to the power 12 minus 4. It's going to be b to the power 12 minus 8. Okay, and now we're going to need to finish this. So it's 16 over 9. That's going to be a to the power 12 minus 4 is 8. And b is going to be to the power 12 minus 8, which is 4. And we typically write that as a single exponent. Look back at example 7. 16a to the 8th, b to the 4th, divided by 9. That is the answer for this problem. So one main thing that you should be understanding now, it basically all comes down to applying each property individually and then simplifying that as you move along. Alright, this here, so let's take a look at these problems. Some negative exponents involved. So we have 6 over 18. We are going to subtract the exponents. So it's going to be a to the power 3 minus negative 2. And b to the power 7 minus 4. Okay, so 6 over 18 can be simplified. That's going to give you 1/3. These two exponents here are going to give you 5. And these two exponents here will give you 3. And it's going to be a to the 5th b cubed divided by 3. I'll box that in a moment. This problem, 6 over 18. No, it's actually happened to be the same problem, so that was my mistake. Well, since I already have it here, it is going to be the same answer. Okay. Example 15. So here we have 6p to the power negative 4. You need to be careful. No parentheses, which means your exponent only applies to what goes right before that. So we're going to have 6, and p to the fourth is going to be written as 1 over p to the fourth. P to the negative fourth is 1 over p to the fourth. And then we write that as 6 over p to the fourth. But unlike example 15, example 16 has a parenthesis, which means this negative exponent applies to the whole thing. This is what I always recommend that students do. Since it's a negative exponent, you just take the reciprocal of whatever you have there. So it's going to be 1 over 2t squared to the positive third power. Now you can go ahead and take care of that. So when you do this, it's going to be 1 over parentheses, exponent on the outside, 2 to the third times t to the 6, because you multiply the exponents, 2 times 3. And that's going to give you 1 over 8t to the 6th. In the box, a few of those answers that I got so far. So this is that one. That one happened to be the same by accident. And there you go. Example 17. So we have a negative exponent on the bottom. What I would recommend when you do this problem, just write it as b to the fifth divided by, and here I know it's negative, but we can just multiply the exponent. So 2 times negative 3 is negative 6. And then you apply the property, when you have a quotient, you subtract the exponents. It's going to be b to the power of 5 minus negative 6, which is going to be b to the 11th power. Okay. When you have problems like this, and you see a quotient here, and you're raising it to the negative exponent, what I always recommend, you just reciprocate this. So write it as 2m over p, and now it's going to be a positive exponent. Okay, and now you can apply it to that whole thing. So this is going to be 2m to the third divided by p to the third. Here you have a product, so 2 to the third times m to the third over p to the third. And that's going to give you 8m to the third divided by p to the third. Right? I hope it's beginning to make more sense now. We do have some more challenging problems to look at. So let's go ahead and do this. Yeah. This problem, so we have 6k to the cube t to the fifth divided by 2k to the 8th t to the 4th. First thing we're going to do, we're going to simplify what we can. So 6 over 2 is going to give you 3. It's going to be k to the power, k to the power at one exponent minus the other, so 3 minus 8 times t to the power of 5 minus 4. So what are we going to get here? This is 3 times k to the power of 3 minus 8 gives you negative 5. And then t to the power of 5 minus 4 is t to the first, or simply t. So this one has a negative exponent. So we're going to write here is 3 times 1 over k to the fifth times t. Now we just assemble that together into a single expression, so it doesn't all sit like this. So 3 and t both go on top, and k to the fifth goes on the bottom. For number 20, we saw a problem very similar to that when the negative exponent sits outside and you have a quotient, but you can do some simplifying inside, and that's what I would recommend you do here, because it's going to make things a whole lot easier. So we're not going to touch the negative exponent yet. We're going to get back to it. Let's simplify what's inside. So it's going to be 2 over 5 p to the fourth over p to the seventh, and it's going to be p to the power of 4 minus 7, and q is going to be to the power of 3 minus negative 2. And that all has the negative exponent negative 2 outside. We'll get to that once we're done once we're done with everything inside. So continue on. This is 2 to the 5th. This is going to be p to the power negative 3. And this is going to be q to the power 5. So negative exponents, and of course the whole thing is to the power negative 2. Negative exponents are going to be handled as reciprocal. So 2 over 5 times 1 over p cubed times q to the 5th, all to the power negative 2. So we assemble this together. 2 and q to the 5th go on top. 5 times p cubed goes on the bottom. All this to the power negative 2. So now it looks like that one problem we did earlier. Negative exponent outside. You have a quotient. We are going to reciprocate that. So we're going to get 5p to the 3rd divided by 2q to the 5th. And all that is going to be raised now to the positive 2 power. So now all that needs to be raised to that power. And first we're going to do individually numerator and denominator. That's 5p cubed squared over 2q to the 5th squared. Apply to each one. It's 5 squared times p cubed squared divided by 2 squared times q to the 5th squared. Multiply exponents here, multiply exponents here. 5 squared is 25. P 3 times 2 is 6. Over 2 squared is 4. Q to the power of 5 times 2 is 10. That's the answer here. I think I have a couple more problems. Alright. So the challenge here is we're going to have this negative exponent here, and this is where you have to be very, very careful. Unfortunately, this is going to be more difficult if you try to reciprocate that, because it's going to make things more complicated. So what I suggest you do for these problems, since we have something that we're raising to the power, we're just going to do the following. We're going to say it's a squared to the power negative 4 times b to the negative 3rd to the power negative 4. And on the bottom we have a similar thing with a positive exponent. That's going to be 3 squared times a to the negative 2 squared times b to the negative 4 squared. Okay, so let's take care of all that. Here you multiply the exponents, here you multiply the exponents, here you multiply the exponents, and here. So all that is going to give us a to the power negative 8. B to the power negative 3 times negative 4 is 12, all over. 3 squared is 9. A to the power negative 4 and b to the power negative 8. So what we're going to do now is we're going to subtract the exponents. So that's 1 over 9. It's going to be a to the power negative 8 minus negative 4. Subtract the exponents here. Times b to the power 12 minus negative 8. Subtract the exponents here. So what is all this going to give us? That's 1 over 9. This is negative 8 minus negative 4. That's a to the power negative 4. 12 minus negative 8. That's b to the 20th power. So what has negative exponents still, remember we do not leave negative exponents on our final answers. So 1 over 9. Times 1 over a to the 4th times b to the 20th. So 1, 1 and b to the 20th go on top, so it's b to the 20th. And the bottom is going to be 9a to the 4th. The key here is to very carefully go with all the properties and apply them. Do not try to apply them all at once. That's usually not going to work well. Alright, so here we have 3 exponents. It's not really going to change anything, but we're just going to do step by step and gradually get there. This is our last example. So everything that we have inside is going to gain that exponent negative 2. So it's going to be 2 to the power negative 2, a squared to the power negative 2, b to the negative 3rd to the power negative 2, and c to the negative fourth to the power negative 2. And the same thing is going to happen on the bottom. We have 3 to the fourth times a to the negative first to the fourth times b to the fourth times c squared to the fourth. Okay? So very carefully simplify all that. Well, this is going to be a reciprocal, right? It's going to be 1 over 2 squared, which means it's going to drop on the bottom. So that's not going to sit there anymore. We're still going to have a to the power negative 4, multiply the exponents, b to the power 6, c to the power 8, remember we're multiplying the exponents here, negative 3 times negative 2 is 6, negative 4 times negative 2 is 8. So we're going to have 2 squared on the bottom, 3 to the fourth, multiply the exponents here, that's negative 1 times 4, a to the negative fourth, b to the fourth, and c to the eighth. So, now you have c to the eighth on top and c to the eighth on the bottom. They're the same exact variable, same exact exponent. You can actually cross it out and you don't have to worry about this anymore. So c is irrelevant here, right? But we still have to do the, oh, and a to the negative fourth on top and a to the negative fourth on the bottom are actually going to simplify as well. They can cross out. So that makes your problem a whole lot nicer. It does happen sometimes like that. So we still have b to the sixth. So it's going to, well, let me rewrite what we have so far. It's b to the sixth, and let me take care of the numbers. 2 to the second power is 4. 3 to the fourth power is 81. And you have b to the fourth. So we have to subtract the exponents. 4 times 81 is going to be 324. And here we're going to have b to the sixth power minus 4. Subtract the exponents, which gives you 2. So it's 1 over 324 times b squared. B squared goes on top. Your final answer should be written as b to the second power over 324. And that concludes this problem. And that concludes our lesson. I hope this was helpful.